Hello. You should see the desktop by now. Can you hear me and see the desktop?
Yep.
Yeah.
Yeah. Okay. Let me see. And oh, it looks like everyone's almost here. Okay. Is everything? Let's see. Oh, no, I don't have speaker on. I had my speaker turned off. Is everything okay? Is everything? You hear my voice?
Yes.
Okay. Yeah, I had my speaker turned off, so I didn't. If anybody answered a minute ago, I didn't hear it. Okay. Okay. Ready to start another week. Okay. So, last week we had the test. It won't be graded for about a week. It's going to take a while to grade the test. So, and so don't, you won't see a grade up there on Brightspace for probably at least a week. Okay. And there's going to be another programming assignment real soon. Right. Yeah. There isn't one yet. There's still the 3 here, but this was due a week ago. So there'll be another one up there in a day or two. And we're going to start maybe not quite today, but we're going to start a new topic, loops. But we still haven't quite finished these last 2 sections on if statements, which are also very important for what we're going to talk about now, because this is actually the bridge between if statements and loops, talking more about logic. Okay, so these 2 sections here are just as much about what we're going to do with loops as they are with if statements. Okay, all right. So we want to do these 2, talk a little bit about these 2 sections. Okay, right. And let me think, see if there's anything I want to remind you of. Okay. So start this reading, start reading these sections, and we'll definitely on Wednesday we'll be talking about loops. Okay. Now, when we write if statements, we have to say if something's true or false, then we do one thing or we do another thing. Okay. So if I start up Dr. Java. Okay. The whole thing is, if you put something in between here, and then you have what to do if it's true, else what to do if it's false. Okay. And the key is what goes in here. Okay, what goes in here is something that's true or false. But what we mean is something, what goes in there is a Boolean. Okay, so what goes in there is something that is Boolean. Okay, and we've learned a bunch of things that can be Boolean. Let me show you. I remember. I made it a little. I didn't point it out, but I created a little zip file of tables from textbooks that I think are good summaries of information. And I'll show you why I brought that up now. So click on this and download that zip file and extract it. And these are just from a few textbooks, little tables. Like here's the escape sequences we've been using, okay? For like we've been mostly using /n or /quote for, okay? And then here's a summary of the primitive data types, int, double, char, Boolean. Okay, now what I want to bring up was, what do we know that's Boolean so far? What do we know that can give you true or false? So far, the one we've had that does that are the relational operators. Okay, these have been the things we've been using in if statements. If something is equal or not, so it's either true or false. Something's not equal or not equal. Something's either not equal or not equal. So those are things that are true or false. You're either less than or not less than. So these are the relational operators are Boolean operators. Some people call them, they're one of the kinds of Boolean operators. They give you back answers that are true or false. Okay, and what else did we have that gave us answers that are true or false? If you go over here to the some useful methods of string objects, we had equals and equals ignore case that return Boolean. See, so that was something that returned Boolean. Okay, so those two methods. Now, if you notice, none of the other methods enlisted in here are Boolean. Okay, they don't, but these two tell you, they give you an answer is either true or false. And then if you look in there's another table of string, like this table was with your homework assignment. This table was in the homework assignment. Then there's this other table, a shorter table of string methods, but it has two more Boolean methods. Ends with, okay, you could ask if a string ends with, I can't click on that. Okay. You can ask if something, if you can ask if a string ends with some other string, and the answer is true or false. And you can ask if a string starts with some other string, and the answer is true or false. Okay, so there's two more Boolean things. So we've got a few Boolean methods in the string class, and we've got the relational operators. So far, that's what we have for giving it. That's what we have in Java that can tell us things are true or false. Okay, so we've got the Boolean operators, which work on numbers, and we've got a few methods in the string class. Okay, so things like here, I can ask if HELLO, that's a string. I can ask, does it start with capital H? Okay, there's a Boolean expression. Okay, I can't compile this because I haven't made it a part of a program yet. Okay, actually, if I take this and put it in the Java Visualizer, nice thing about the Java Visualizer is it gives you a main method automatically. So go over to the Java Visualizer. Okay, let me put it where it belongs. Okay, now actually that's a real program. I don't actually have to do anything in here. If I, oh, let's see what I do. Oh, I forgot the parentheses there on the method call. Notice that it's actually a real program. Okay, now this one's false, but there was nothing inside there to do. So let's go back and let's put something in there. Now, if we just want to put something in there, we could just say int A equal 1, int B equal 2. Notice that's a kind of a silly line of code. It doesn't do anything, but at least lets me know if I'm jumping into here or into here. See, I jumped into here. That was false. See, it's a Boolean expression. It was false, so I jumped into here. I'm not doing anything, okay? But at least we see which branch it took. And then if I put H here, that one was true. See, I'm using a string Boolean expression, okay? And yeah, and then I can mix things up with strings and Booleans. For example, if I ask 5 equal hello dot length, okay, that's actually a Boolean expression about numbers. It's asking if 5 is equal to the number returned by the length of hello. Okay, now hello is 5 units long, so that one's going to give me true. Okay, so I jumped in there. That one gave me true. And if I ask something like, well, is 5 not equal to? Okay, this one's false now because 5 is equal, so that one's false. So I jump into there. Okay, right. So what we want inside here is anything that gives us an answer of true or false, anything that's a Boolean. We can use the relational operators like this. So here I use the relational operator between numbers. One number came from a string, and the other number was just this number here. Or I could use string methods like we had a minute ago, string methods that return true or false. Okay, now what we want to do is start asking more complicated questions. This just asks one thing, if it's true or false. But in the real world, a lot of times you do things like ands and ors. You say, yeah, I have to go to work and I have to go to the grocery store. Yeah. Or you say like, it's Saturday, I'll go to the beach or I'll go to the fair. Yeah. So you combine things with ands and ors. Okay. So we want to start to say a little bit about combining Boolean expressions. Okay, so that's what we're really talking about. This is what we call compound Boolean expressions. Or another way to say is you want to take Boolean expressions and combine them with and or. And then there's also this thing not, which isn't actually combining anything. Not just takes the opposite of what your Boolean expression is. So if you have a Boolean expression, you put not in front of it, and it just turns it into its opposite. This is really what we're interested in. The combining is what's real useful. Combining two Boolean expressions with and, or combining them with or. Okay. So over here, I can do a silly little combine. Okay. Here, so 5 is the length of hello, and hello dot ends with okay. Okay, so there's a combined expression. Okay, I'm saying that 5 is the length of hello, and hello ends with LO. Okay, now is that true? What does it mean to say that something's true when you're combining with and two things? Okay, what is it you're intuiting? What do you think? If you say this is true and this is true, the answer should be what?
True.
The whole thing is true. Okay, so that's the case here. If the whole point of and is that, see, if both of them are true, then the combined thing is true. But if I make one of them false, okay, now look at this. 6 is the length of hello, and hello ends with LO. Well, this one's true, but this one's false. So when you say and, the result is, well, it's false because you didn't get both of them. You got this one's false, this one's true. So then the result is false because you didn't get both of them. Oh, look, their website hung. See, assertion failure. Consider log for, okay, you get something went wrong on their website. Probably just click OK and try again. Ooh, it's still grayed out. Okay, if this happens to you in the visualizer, here's what you do. Usually you can still copy your code, see, copy it, and then refresh the page. See, it's kind of really hung, but you have to copy your code before you refresh the page because otherwise you lose your code. So refresh the page. Now paste my code back in. Okay, and I should be okay. Little trick for every once in a while, their website hangs on you. It's like any other website. You have to be very defensive when you do your work on websites because they can easily hang up on you. So you start getting used to like, what can you do to try to save your work if you think a website's hung up on you? Okay, so now if I remember, this one was false and true. The result is false. Okay, you can see now I'm down here in the false case. So false and true is false. Okay. Now, if both things are false, yeah, if it's if this one's not true and this one's not true, well, sure, the whole thing's not true. What's interesting in the case of and is how it's not true if one of them is true and one of them is false. Okay. Now, what about or? What if I change this to or? Oh, notice how we don't write the word and. It'd be kind of nice if Java let you write the word and. There's a few programming languages that let you write the word and, so you could read that in a more natural way. Java follows the pattern of the older languages like C and C++, and they're the ones who invented this double ampersand thing to mean and. That goes back to C. Okay, and languages that more modern languages, when people invent languages today, like some more modern languages like Haskell and some other ones, they actually just let you write and or. There's no real reason to use some cryptic little symbol for these things. We have nice words for them. They're nice short words as it is, but all the C started this idea of using these funny symbols for and or. This is really the C language, and Java follows C, and JavaScript follows C. Okay, so now or is written in a real funny way. At least this makes a little bit of sense because that's the ampersand symbol, which is a single and is an abbreviation for the word and. Okay, but if you type a single and there, you don't get the right thing. Okay, that's not, unfortunately, it compiles, but it's not the same thing as double ampersand. A single ampersand does not mean the same thing as double ampersand. Sometimes you'll get your programs to work and sometimes your programs won't work right because it has a different meaning. And later on we'll learn, well, probably not even in this class. Next year you'll learn what the single ampersand means. Okay, so you need to use double ampersand, okay? And then or is double vertical bar. Okay, now it's true that in some places a single vertical bar means or. There are, probably you haven't seen that, but it's actually not that unusual to use a single vertical bar to mean or. Just like a single ampersand means and, a single vertical bar does mean or in some places. Okay, in some writing, and certainly in a lot of sciences, they use a single vertical bar as or. But here you have to do two vertical bar. Oh, single vertical bar works, but it's not what you want it to be. Okay, it's not. So for us, it's two vertical bars to mean or. Okay, so you got to remember that two ampersands for and two vertical bars for or. Okay, now or here 6 is the length of hello. That's not true. But then it says or hello ends with low. Okay, so if one of these is true, I ought to be okay because I said or. And that's what's going to happen here. I want one or the other to be true. Okay, so since I had this one was false, but this one was true, I still ended up in the true case. Now, what makes or false is if neither of them are true. Okay, so or is false when neither of these is. You want this is true or this is true, but this one failed, this one failed. You didn't get either of the conditions, so now this one is false. Okay, we got the false case. Okay, now if you keep a running score of this, you might, here's how it works. If and needs both of them to be true. So true, true makes it true, but false, true makes it false. True, false makes it false. False, false makes it false. So out of the four possibilities, true, 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 false, false, true, false, false, three of them make this false and one of them makes it true. On the other hand, if you go to this one, there's four possibilities. True, 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 false, false, true, false, false. Okay, which ones work? Here, both of these being true, well, if you ask if this is true or this is true and they're both true, that should be true. We just said a minute ago, if one of them is true, then the whole thing is true. So if you get true, false, that's true. If you get false, true, that's true. And if you get false, false, that's when or gives you false. This, what we just talked about, is something called the truth table. So if you look in this little folder I gave you of tables, there's something called the, where is it? Oh, I didn't put it in there yet. Okay, let me get it out of my folder. Yeah. I have to update that folder to include the truth table. Let's see if I remember where it is. There's the two truth tables. I need to add them to that. I didn't have them up there last week because we hadn't talked about this yet. So now that we've talked about it, I should add them to that this folder. Okay, so there's the two. Now, what does a truth table look like? Truth table is a way of summarizing what a ands and or do. So you have something on the left of the and something on the right of the and. Okay, so here they call A is the thing on the left, B is the thing on the right. Okay, suppose the thing on the left is true and the thing on the right is true, then the and is true. If the thing on the left is true and the thing on the right is false, the and is false. And if you have false, true, the and is false. If you have false, false, the and is false. Okay. Now, here we're going to use the same A and B, but put them around or. Okay, so we're doing the truth table. This column here is the truth table for or. If the thing on the left is true and the thing on the right is true, then the or is true. If the thing on the left is true and the thing on the right is false, the or is still true. And if the thing on the left is false and the thing on the right is true, the or is still true, and it's false when it's false, false. Notice that this has got 3 trues and a false. This has got 3 falses and a true. They're kind of a little bit like opposite of each other's. True, false, 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 true, 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 false. Okay, those are called the truth table. Okay, now one thing that's important about this is that the or in this truth table is actually not the or that you usually use in the English language. Okay, think of, here's a couple different sentences in the English language that use the word or. Let me see, let me take a remember. Okay, you ask a little kid, do you want ice cream or a cupcake? Okay, to the little kid, he says, well, or is true if the left on the one on the left is true and the one on the right is true. So I want to make that statement true. So the kid says ice cream, cupcake, both. But that's not what you usually mean when you say this or. You're asking the kid to make a choice. Okay, this or has actually got a name. It's called the exclusive or. It excludes the case of this one, of both of them being true. Okay, if they both in the exclusive or, which has got a different, there's actually a symbol for it in Java, but we don't need it. We won't need the exclusive or, but it's actually got its own symbol. In the exclusive or, true, true is false because you're not allowed to choose both of them. The exclusive or would be true, true gives you false. And that's what, and in English, you have sentences like that. Do you want ice cream or a cupcake? You're excluding the, now, let's see, I'm trying to think of an English sentence that uses inclusive or. Sometimes in English sentences you use inclusive or. Well, I'm trying to remember an example. Does anybody think one real quick where it's okay in English to have both of them be true? I think they had an example on the website. Let me look. See, here's where they explain it. Okay. Here's a little explanation. Yeah. We often use exclusive or. Okay. Oh, they don't give an English language example of the inclusive or either. Oh, they give an English language example of the exclusive or, which is the more common one even in English. And they don't even give an example of an English language inclusive or. I'm trying to remember an English language example of inclusive or. They're less common in English. In programming, or always means now inclusive or inclusive OR is what this one is, because it includes the case that you can just do true, true. So you're including that case. So true, true gives you true here. Okay. So that's and so programming OR is the inclusive OR. And I have to think a little bit about an English language example, which naturally is this is naturally the exclusive OR. You don't mean for the kid to choose both. He's got to make a choice between this one or that one. I can't think of one offhand of an English. Most English language ORs tend to be inclusive OR, exclusive ORs. Okay. All right. So the truth table for inclusive OR is different. Okay. There's a different symbol for it, and there's the truth table for inclusive OR would be false, true, true, false. Okay. All right. Now there's also the not operator, which just not just takes one thing. The not of this just negates it. So if A is true, not A is false. If A is true, not A is false. If A is false, not A is true. So you take the opposite of what's inside there. Okay, so we've got these. Oh, and let me show you. There's another picture of the truth table in that folder. Some people, like this truth table, showed them all lumped together. This is actually the way people usually. Well, this one showed them lumped together too. Well, it showed the and or lumped together, then the not is over by itself. See, if this is the thing if this is the thing, the not of the thing is opposite of what it was. So if the thing you're nodding was true, not P is false. If the thing you're nodding was false, not P is true. Then over here is the and or, okay? True, 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 false, false, true, false, false. There's 4 possibilities, and there's the truth table. Okay, so this truth table, a lot of times people just make a truth table for and a separate truth table for or. Here they're just combining them into one. Okay. Also, I don't know if you ever heard the phrase "mind your P's and Q's." It's kind of an old-fashioned phrase, but this is where it came from. When people write logic formulas for some, like in algebra class, you use x's and y's for your variables. Traditionally, in logic, they use P and Q for the variables. So when people were taught logic, they had to mind their P's and Q's. Okay, so that became a phrase for it's actually kind of a phrase for being correct or being polite or being careful. Mind your P's and Q's. So it came literally from being taught logic and using the variables P and Q instead of X and Y. Or in this case, this person's used A and B for the variables. A just represents anything that's on the left side. So in our Java visualizer example over here, that's the A in the truth table. And that's the B in the truth table. Okay, or the Q. That's the P. So this is what's on the left-hand side of the OR, and this is what's on the right-hand side of the OR. Okay, so the truth table just represents whatever's on the left-hand side, no matter how complicated it is, by A, and whatever's on the right-hand side by B. And the A and the B, and we'll see, could even themselves be compound. You can start combining these things just like you do algebra. If you have x plus y in algebra, you can write x plus y. That's a compound statement made up of 2 numbers. But you can also replace x by w plus z plus y. You can replace that guy with something that's more complicated. Just put parentheses around the more complicated thing, and then that thing replaces the x. Similarly, you can replace this y with something more complicated. Okay. Yeah. And then there's nothing to stop you from replacing w with something. You can replace w with something more complicated. You can end up with okay. This is still something plus something. So it's still this thing here. It's still a something plus something. But the something on the left is this whole complicated thing. and the something on the right is this. Okay, so you can what we call nest the expressions. Okay, so we can do that with ands and ors too. Yeah, if I have A and B, there's nothing to stop me from replacing the A with something like X or Y and B. Okay, I replace the A with something more complicated. Okay, and then I can replace the B with something more complicated. I can replace the X with something more complicated. Okay, so you can create what we call compound Boolean expressions, and you can make these things as complicated as you want. Okay, and we actually used an example of that in class the other day. Let's go to an example we did the other day. We were testing numbers. Which this was remember we said we asked the user to input a number between 1 and 5. If n is 1, you entered 1. If n is 2, you entered 2. If n is 3, you entered 3. If n is 4, you entered 4. Now, what happens when they didn't enter 1, 2, 3, or 4? We wanted to print an error message. But notice this said, here's the compound expression. If their number's not 1, and it's not 2, and it's not 3, and it's not 4, and it's not 5, then you can give them an error message. Okay, so notice that this is a compound expression made up of lots of ands. How do we know they didn't type in 1, 2, 3, 4, or 5? We have to ask that the n is not 1, not 2, not. Now, this thing can be made a little bit simpler. Here's two other ways of writing this one. So instead of writing it that way, I could have written it this more simple way. It's still a compound expression. Okay, now what does it mean to be not 1, 2, 3, 4, 5? If an integer is not 1, 2, 3, 4, 5, those are 5 consecutive numbers, 1, 2, 3, 4, 5. You could have come from less than there, or you could have come from more than there. You could be less than or equal to 0, which means you're on the left of the 1, 2, 3, 4, and 5, or you could be greater than or equal to 6, which means on the number line, you're to the right of the 1, 2, 3, 4, 5. So this is another way of saying this one down here, a much easier way of saying it. And then here's even a slightly simpler way of saying it. If n is strict, this one said if n is less than or equal to 0. Well, these are integers, okay? 0 is the next number after 1. So you could just say, well, if n is strictly less than 1, now I said these are not the same thing for decimal numbers. N less than or equal to 0 is not the same thing as n strictly less than 1 for decimal numbers, because there's numbers in between 0 and 1. They're decimals. But for integers, there's nothing between 0 and 1. So being 0 or to the left on the integer number line is the same thing as being strictly to the left of 1. So draw yourself a number line and convince yourself of that. Okay, being equal to 0 or less on the integer number line is exactly the same thing as being strictly to the left of 1 on the integer number line, because there's nothing between 0 and 1 on the integer number line. Same thing here. Greater than or equal to 6 is the same thing as strictly greater than 5. So I could have written this, I could write this test any one of these three ways. Three different now this is why logic's tricky. Three different compound Boolean expressions that all have the same meaning, but this one's maybe easier to read. You're not 1, not 2, not 3, not 4, not 5. But on the other hand, this one's much shorter to write. You're strictly less than 1, or you're strictly greater than 5 is the case where you didn't type in 1, 2, 3, 4, and 5. Okay, so it's real natural to come up with these compound. These things come up in pretty straightforward ways. There's no real great way to learn this. This is not algebra like high school algebra. This is actually much harder than high school algebra. You usually learn to write these by just thinking in English, real hard. I want to be the case where somebody didn't give me 1, 2, 3, 4, or 5. How would I say I didn't get 1, 2, 3, 4, or 5? Well, you can say, well, I didn't get 1, and I didn't get 2, and I didn't get 3. So you just kind of like think out, well, I didn't get any one of these 5 numbers, so just say that. if I didn't get 1, didn't get 2, then you might think a little bit, think on a number line. Okay, I'm not between 1 and 5. Well, if I'm not between 1 and 5, I could be to the left of 1 or to the right of 5. There's no algebra to this. There's no straight route to the right answer. It takes practice. You just have to solve lots of problems, and you start getting used to thinking logically, thinking using ands and ors. It's a little bit tricky. We'll do some examples in Coding Bat where they have some really nice problems where you have to think very creatively about using ands and ors to solve what are kind of contrived problems, but they're not really contrived. They sound contrived if you're a beginning programmer, but if you've been programming, you'll see that the Coding Bat problems are not contrived. Every one of them is the kind of real world problem you solve when you write real big programs. So they give you these little tiny problems that seem contrived, but they're not. Okay, like this. This isn't contrived. This is something you would see over and over again in programming in problems. A real programmer would never write that one. A real program would write either this one or that one. That one can be considered the right way to do this, just because it's so much shorter. Okay, but they're all three the same. There's no real difference between these two. Some people would like it this way. Some people would prefer it this way. Very few people would write that way, but they might. It's still logically correct to write it this way. Okay, all right. So there's an example of a compound expression that helped us ask when was the number not 1, 2, 3, 4, or 5. Oh, notice I used notice what I just said. The number is not 1, 2, 3, 4, 1, 2, 3, 4, or 5. The number is not 1 or 2 or 3 or 4 or 5. That brings up kind of a weird thing. What I just said was, I'll type it in here. The number, oops, not 1 or 2 or 3, 4, 4, or 5. The number is not 1, 2, 3, or 4, 1 or 2 or 3 or 4 or 5. That was the same thing as the number is not 1 and not 2 and not 3 and not 4 and not. This is tricky here. The number is not 1 or 2 or 3 or 4 or 5. More or less means it's saying the number is not 1 and not 2 and not 3 and not 4 and not 5. Okay, this is actually something called De Morgan's law. De Morgan's law is written this way. If it's the not of P or Q, that's what I have up here. It's not, the not's really in front of this group here. It's not 1 or 2 or 3 or 4. So this is really got a pair of parentheses around it. The English doesn't put it that way, but there's really a parentheses around it. De Morgan's law says not of P or Q is the same thing as not P and not Q. And here, if I want to put parentheses, it would look like this. And that's what this said. This is not 1 and not 2 and not 3 and not 4. See? Now, without the parentheses, you can just say, in English, if I say to you, the number is not 1 or 2 or 3 or 4 or 5, and if I say, but the number is not 1 and not 2 and not 3 and not 4 and not 5, you would know that those are saying the same thing. These are saying the same thing, though you usually wouldn't say it the second way because it's too long. So you usually just abbreviate it. The number is not 1 or 2 or 3 or 4 or 5. But that's using something called De Morgan's law that says the not of something or something is the same thing as not the first thing and not the second thing. De Morgan's law drives people crazy, but they actually know it because in English, this sentence means the same thing as this sentence. You kind of instinctively if I say the number's not 1 or 2 or 3 or 4 or 5, you know, okay, it's not 1, it's not 2, it's not 3, it's not 4, it's not 5, which is what this longer one says. Okay, but this thing can get hard to use. Okay, and every once in a while we will use De Morgan's law to make things. See, it took this long thing and made it shorter. De Morgan's law could take a long thing and make it shorter. Okay, see, this right-hand side is a little bit longer than the left-hand side. There's one knot around a grouped P or Q. Here you have a knot P and a knot Q. So it's a little bit longer on this side. Sometimes this side, what we do is, given the choice between the left-hand side and the right-hand side, usually it's which is easier to read or which is shorter. Here, this one's shorter. They're about the same to read. Sometimes the left-hand side's easier to read, sometimes the right-hand side's easier to read, sometimes you just pick the one that's shorter. There's also a version of this for and. It's not the case that P and Q. If it's not P and Q, that's the same thing as saying not P or not Q. Okay. Now here I'm mixing up English. You know, the exclamation mark is the one for not. Actually, let me go back and let me make them all nots. Not P or Q. Not P and Q is not P or not Q. Okay. Okay. These are De Morgan's law. If it's not the case that I have one or the other, if it's not the case that I have one or the other, that's the same thing as saying I don't have this one and this one. See, I don't have one or the other. I don't have wealth or fame. So that means the same thing as I don't have wealth and I don't have fame. I don't have wealth or fame. I don't have wealth and I don't have fame. Okay. Yeah. Think. I don't have wealth and fame. I don't have wealth and fame. So I'm saying I don't have both of them. Well, I might have one of them. So I either don't have wealth or I don't have fame. To say I don't have both of them means, well, if you don't have both of them, you could have neither of them, but you could have one of them. That's what the or does. It says, or says either I don't have wealth or I don't have fame. So if you think about these in terms of enough English language versions, they start making sense. Not P or Q is not P and not Q. Well, that's hard. That doesn't mean much to anybody. But if you say it's not the case that I'm rich and famous, or I'm sorry, it's not the case that I'm rich or famous. I'm not rich or famous. Well, I'm not rich and I'm not famous. If you say it's not the case that I'm rich and famous, that means I'm not both of them, but I might be one of them. Okay, so I'm not both of them. That's true when I'm not one of them. Okay, those are called De Morgan's laws, and every once in a while we'll make use of them. Okay, and they're symmetric. Not P or Q is not P and not Q. Not P and Q is not P or not Q. So you get one from the other by changing the ors to change that or to and, change that and to or, and there you get the two versions of De Morgan's laws. Okay. So you can take things that are long like this and make them shorter. So if we go back over here, this guy's got a slightly shorter version of them that looks like this. There's another version of this one. Okay, so there'd be another version of this one that says it's not the case that n equals 1 or n equals 2 or n equals 3 or n equals 4 or n equals 5. Now notice, oh, then I need another parenthesis, right? Okay, so n is not 1, and n is not 2, and n is not 3, and n is not 4, and n is not 5, and okay, the same thing is saying it's not the case that n is 1 or 2 or 3 or 4 or 5. Oh, let me show you what you can't write. Now notice how I read that. It's not the case that n is 1 or 2 or 3 or 4 or 5. Kind of the way I wrote it here. Not 1 or 2 or 3 or 4 or 5. Java won't let you write that the way you read it. Here's something that would be wrong. You can't write n is not, it's not the case that n is 1 or 2 or 3. This would be nice if you could write it, but it's not the case that n is 1 or 2 or 3 or 4 or 5. You might write, yeah, you might think, oh, that would make sense. It's not the case that n is 1 or 2 or 3 or 4 or 5. That's exactly what I wrote in English over here. That which you would have no trouble reading that in English if you wrote that as this way. The number is not 1 or 2 or 3 or 4 or 5. Okay. Java won't let you write it that way. You can't just say 1 or 2 or 3 or 4 or 5. N is 1 or 2 or 3 or 4 or 5. You can't write it that way because one's not a Boolean. So that doesn't make sense on the left of an or statement. An or statement has to have something that's true or false on the left and something that's true or false on the right. So that's not something true or false on either side. So it makes sense to us if we read it. If n is not, if it's not the case that n equals 1 or 2 or 3 or 4 or 5, that reads to us like English, but that isn't valid log. That isn't written in Java properly. So there's a lot of really tricky things going on here. You try to solve these problems by thinking in English, but then you have to translate your English into Java kind of carefully. So this one makes sense if you just literally translate it from English, but it isn't going to give you proper Java. It's the literal translation of this one into English. Like if n is not 1 or not 2, n is not 1 or 2 or 3 or 4. But you have to say n is not, if it's not the case that n is 1 or n is 2 or n is 3 or n is 4 or n is 5. You can't just say if it's not n is 1 or 2 or 3 or 4 or 5. Okay. Compound logic is not simple. It can get very tricky pretty quickly. Okay. And practice is what this thing, you get this by just doing practice. We just solve lots of problems using ands and ors and nots, and you start getting used to the way you can think with these things. Okay, now let's turn to another aspect that uses ands and ors and nots. We have the relational operators. One of the important ones is equal and not equal. In this case, like, are two numbers equal? Are two numbers not equal? One of the messes in Java is you can't use these on strings or on, for example, turtles. You can't use the equal, equal, and not equal operator on objects. Okay. Now, in the book, that's this next section. We've been talking about the compound operators. So we talked about these. Yeah. Oh, there's the truth table in the book. See, there's the truth table. Okay. We talked about this stuff. Then the next section was comparing objects. Okay. What happens when you want to ask if two strings are the same, or if you want to ask if two turtles are actually the same turtle or not? Suppose you really wanted to ask, is turtle A, remember we've seen that you could have aliases between turtles. So you could have A and B both be names for a turtle. And like you might want to know if they're really the same turtle or not. Okay. Or you might have two strings and you want to know if they're the same string or not. Okay. So you can't do that. me start another if statement. I'll keep that one, just if. Okay, so now I just said you can't do that, but let's see what happens here. Okay, I'll just like I'll do the same thing. I just want to know which branch it takes. Int a equals 1, else int b equals 2. I just want to know which branch I took here. Okay, if hello is equal to hello, no, they're not equal. So I expect to take the false one here. But I really shouldn't be doing this. I shouldn't be, notice that, huh. It skipped line 13 and went straight to here. Huh, that's, yeah, this thing's false. And it's funny, notice that it just, if I do back, it just skipped over even asking this question. That's kind of a quirk of the visualizer. This thing's false and it just skipped over it because it didn't need to act. I guess it knew it was false even before we started. Yeah, it's funny. I didn't even know the visualizer would skip over something that it knew is false. Okay, so it went over to here. Okay, so it took the false branch. Okay, now suppose I ask, what if they're not equal? Okay. Okay, that's true if they're not equal. But this is not really working right. Okay, now let me show you, let me rewrite this. I can create a string by using new. We don't do it very often, but we can do this. Okay. Okay. And let me go make it simple. Is new string hello equal to new string hello? Okay. See, that looks exactly like that. So you expect it to take the true branch, that this thing equals that thing. Took the false branch. There's something wrong. New string hello, new string hello. I spelled them exactly alike, okay? But it took the false branch. It didn't take the true branch. You're not supposed to use this when you compare strings. It worked a little while ago, but it didn't work here. So let's investigate a little bit about strings to find out what's going on here. Okay, notice that it seemed to work at first and then it didn't work. Yeah, it seemed to be okay to just compare two strings, and then all of a sudden it isn't okay. Okay, so let me start another Java visualizer. This is actually a real source of problem for beginning programmers. Okay, string a, okay, I'll just call it string 1 equals cat. Okay, string s2 equal cat. Okay, so far so they should be the, you know, then string s3 equal, now I'm going to do it the other way, new string cat. Same, it should be the same string. I'll do another one, s4 equals new string. So I've got 4 strings and they all hold the letters CAT. Okay. Let's watch how Java, now here's something. Remember I told you the Java visualizer visualizes strings wrong. If you go over here, you get no help. This doesn't help you understand what's going on at all. To see what's really going on, you've got to tell .visualizer to visualize the strings the right way. Then you see something really unusual going on. there's the first cat. Look, string 2 is an alias for that cat. See, we created that string, and then string 2 became an alias for it. Okay, but now look at the next one. The new actually created another string object, and it's not an alias for that one. And this one created another string object. Okay. Now the question is, what's that got to do with equal? Okay. S1 and S2 really are equal in terms of using the equal sign because they are the same arrow. Okay. So over here, I can say Boolean. I'm going to store Boolean, B1 equals string 1 equal string 2. Okay. So I want to ask the question, is string 1 equal to string 2? I also want to ask the question, Boolean, B2, is string 1 equal to string 3? Okay, string 1 holds cat, string 2 holds cat, string 3 holds cat, string 4 holds cat. Is it true that S1 equals S2? Is it true that S1 equals S3? Okay, and store the results. Okay, B1 is true because those two variables hold the same arrow. But this one is false because the arrow in S1 is different than the arrow in S3. This question asks about arrows. When you use the equal operator on objects, you're really asking what arrow is in the object, not what data is in the object. Okay, so the thing to remember is when you have objects, equal asks about the arrow, not about the data in the object. So what if you want to compare the data in the object? You have to use a different operator. Okay, so the proper way, if I've got objects like S1 and S2, and I want to know if they're the same, I call the equals operator and pass it I call the equals operator on one of the objects and pass the other object as a parameter to it. Notice it kind of reads the same. Is S1 equal to S2? See, is S1 equal to S2? But it's done with a method. Okay, S1 dot equals. I'm calling the equals method on this one, and I'm actually asking this object to compare itself to that object. Okay, then I could do Boolean B4 equal S1 dot equals S3. Okay, notice that, so this one you might think is the same as this one. And this one you might think is the same as this one. Okay, but they're not. Well, this one will give, this one, B4 will give us the same answer as B1, but for a different reason. This is comparing arrows. Okay, and this one compares arrows, but this one compares, what we should think is it compares data in the object. It actually looks inside the object and compares the data in the object. Okay, so this compares arrows, this is comparing arrow, this is comparing the data in the object. Okay, and same with this one down here. This one's going to be compare, the equals method compares data in that object versus data in that object, which is usually what you really want with objects. You want to know, does this object hold the same data as this object? On very rare occasions, you want to know, does this reference variable point to the same object that this reference variable points to? Compare the arrows. Does this reference arrow point to the same object that this points at? Okay, now if we visualize this, S1 and S2 are actually pointing to the same object. So they have the S1 and S2 hold the same arrow. S3 and S4 are individual strings. So we have 3 strings. We have 4 string variables and 3 strings. Okay. S1 equal to S2 is true because S1 and S2 are pointing at the same, they essentially hold the same arrow. S1 equal S3, well, S1 is an arrow to there and S3 is an arrow to there, so those are not the same arrow. But now this asks, if you look inside of the object that S1 points at, and you look inside the object that S3 points at, if you look inside this object and compare that to what's inside that object, what do you get? The same thing? And the answer is true. Okay, so B1 asked if they had the same arrow. B3 asked, does that one and that one, well, actually, I'm sorry, this one asked to look inside of that same object twice. Okay, B3 actually compared that object to himself. So line B3 compared that object to himself because S1 points to that object and S2 points to that object. But this one here now compares this object with that object, and they are holding the same thing. Okay, tricky. Okay, this compares arrows, this compares data when they are reference variables. Now, if they're primitive variables, you can't use this. Okay, so now let me show you, like, what if I have primitive variables? Int x equal 5, int y equals x, Boolean b5 equals x equal y. I'm asking is x equal to y. Okay, well, but this will not work. Notice here I could do equal or equals. Here I can do equal, and it's asking, is the number in x equal to the number in y? What's wrong with this? Real quick. What would be wrong with that? So we see Java's not going to let me compile this. What's wrong?
Is equals only for strings?
Yes. No, not strings. A little bit more general. It's equals is for what? I use the example of strings, but what I say? It's really for what?
Characters?
No. String is an example of what kind of variable in Java?
It's not primitive, it's the other one.
Yeah, not primitive. The other one, which is objects. It's an object variable. Yeah. So it's equals is only for object variables, variables that refer to objects. So strings and turtles, those are actually about the only objects we've had so far, strings and turtles. We haven't introduced any other real examples of objects, but equals would work on turtles and it'll work on strings. So it works on objects, not on primitives. So error, int cannot be dereferenced. See, notice that they don't say that int's not a dereferenced is the fancy word for there's an arrow there. Okay, dereference means you follow the arrow. So the error messages are always written in a sophisticated language. Int cannot be dereferenced. That means that int doesn't hold an arrow and you can't follow the arrow because you cannot dereference it. Okay, so this is not valid. You can't ask for equals on a primitive data type. But okay, so then I should comment that out because it doesn't work. So primitive data types, I've got primitive data. This asks, is the data in that box equal to the data in that box? Which is actually what this did here. It asks, see, is the data in that box, which is an arrow, equal to the data in that box, which is an arrow, and those two arrows point to the same thing, so they're equal. They're the same. We notice that they're actually two different arrows, but in Java, since they point to the same object, they're considered the same arrow, since they point to the same object. So kind of to us, it looks like they are different arrows. Turns out that they're not really arrows, they're addresses, and the address that this thing holds is the same as the address that this holds. Essentially, this is like a house on a street, and what this thing is its address. So the address of this is the same as the address of this. So it's the same. You're referring to the same object. You refer to them by their address. So what actually is in S1 is something we'll eventually call an address. So S1 and S2 hold the same address because they're pointing to the same house on the street. Okay, so they actually are equal. What's in S1 is equal to what's in S2, just like what's in X is the same as what's in Y. 5 in here, 5 in here. Whatever address is in there, that exact same address is in there. A different address is in here because it's pointing to a different house. If you think of these as actual objects, he's got an address, he's got an address, and this one's got an address. There's 3 different addresses, so there's one that's considered the same arrow. That's a different arrow. That's a different arrow. Okay, so this compares what's in the actual box. What's in that box? What's in that box are the same. What's in that box versus what's in that box? Different. What's in that box versus what's in the X box versus the Y box? The X box is 5, the Y box is 5, so that one's true because they have the same thing in the boxes. Okay. All right. So you use equal equal on primitives and you use dot equals on objects. You can't use dot equal on primitives. You can use equal equal on objects, but you better be careful. It's probably not what you want. Okay, so it's complicated. You can only use equal equal on, on primitives. You can only use equal equal. On objects, you can use one or the other. You should remember to always use the other. It's almost never the case that you want this one. Very rarely do programmers want to know if there's the same arrow in 2 variables. It's not very often that you want to know, does this reference variable and this reference variable hold the same arrow? You'd have to have good reason. You have to really know what you're doing to ask that question. You almost always want to know, does the arrow this thing point to hold the same data as what this arrow points to? Does the data in this object, is it the same as the data in that object? You almost always want to compare the data in the objects. Very rarely do you want to compare the arrows in the object. And then what's quirky is string is really strange. If you create strings without the new operator, if the strings are the same, they actually end up being the exact same object. So Java says, well, S1 and S2 are the same. And if I went down here and I created another string, it'll still be see, Java remembers there's that cat up there. You created this cat, and now it remembers it. And it says, oh, if you type cat again, it's this one. If you type cat again, it's that one. But if you say new string, you get a really new string. So this is the subtle difference between using this syntax and using this syntax. If you use this syntax, you always get a new string, which actually almost never matters. Almost nobody ever types new string cat. They would just type cat, cat, cat. But if you really, really, really wanted to make sure that this string was a different object from that string, you would just say new string cat. Okay? But you almost never need that. It's just a quirk of Java. Strings are the only object you can create without the word new. The only object that you can create in Java without typing the word new is a string. Strings are kind of special. So for all other objects like turtles, the only way to get a turtle is to say new turtle. That's the only way you can get a turtle. Okay, so you always have to say new turtle. Okay, with strings, you're allowed to this shortcut. You can just type the string itself and you get a string, but then Java does this shortcut. If you type the same string here, here, and here, you get the same object. But if you type the string in here inside of new string, you get a new object. Okay. The advantage of this, it lets us show real quickly the difference between, it just, here we're just using it to show the difference between two references that are aliases versus two references that aren't aliases. Okay. If two references, like if I create, we created aliases for turtles too. You can create an alias for a turtle just by creating a turtle and then just signing a variable, just saying turtle1 equals turtle2. T1 equals T2 creates two turtle reference variables to the same turtle. Then you could compare them like this or compare them like this. But you should never really compare objects like this unless you really know what you're doing. Okay. All right. So there's a lot of detail in here, and what you have to do is when you have to solve problems, it's really important to keep writing. We're going to start using CodingBat more and more to solve problems, because none of this sinks in for anybody unless they use it. So like just reading it doesn't really work well enough. You have to start using it. But then when you use it, you have to be, what this is supposed to make you do is start remembering that there's things to worry about. You have to, there's a few things you have to remember, like don't compare strings using equal, equal. Just remember that. Don't compare strings using equal, equal. This shows you why. Couple things you have to remember what and or mean. You have to remember that. But then to get used to using these things, you have to just start solving problems. Okay. Now the book has problems built in, so you should make sure you solve the problems that are in the book, because those problems ask you to start thinking about using this stuff. And then I'll start pointing you to, CodingBat has very nice problems. So I'll start pointing you to more and more problems with CodingBat, because we're starting to know enough Java to make use of CodingBat. You can't use CodingBat in week 1 of this class. You have to know a certain amount of Java before you can start doing the problems on CodingBat. And what you need to know to start is strings, if statements, and Booleans. Okay, so you have to have gotten about through chapter 3 of this book to be able to start using CodingBat. When you've gotten through chapter 3 of this book or the other book, same thing, chapter 3, then you can start using code. You have to know a little bit about methods, parameters, if statements, and Booleans. You don't need to use for loops. Next thing we're going to do is for loops. And then there are CodingBat problems that use for loops. But the beginning CodingBat problems use strings and if statements and Booleans. So you have to have at least through chapter 3 before you can start doing CodingBat problems. Okay. Now, see here, here's the pictures of what we just did. See, new string gives you a string high and a string by. Well, actually, here they did new. Then they created the alias the old-fashioned way. They just said string C equal B. That copied the arrow from B into C. So this created the alias by like we would do with turtles. If we were doing with turtles, this if you put turtle here, and then put C equals B, you'd have a turtle here. You'd have a turtle reference variable here and a turtle down here, 2 turtle reference variables, and another turtle here. 3 reference variables, but only 2 objects. So here they're using the new string to create objects. Okay. Let's see where. Oh, they don't mix it up. They actually didn't. See, what we did is they didn't mix. See, here they do it all with news. Here they're using all news. Here they're using all news. Okay. Here they're using news. Unfortunately, that's why they didn't mix it up like we did over here, where we sometimes use this without new and sometimes used it with new. So this example here is a little bit better than the one in the book because it shows you that you have to be aware that you can do it 2 ways, without new and with new. Without new, these guys end up pointing to the same, to each other. With new, these guys are different. Okay, so in the book, they kind of didn't do enough examples. All their examples were using news. See, new string, which is not the usual way you usually would just say S1 equals hello. You wouldn't say new string hello. And they never, in this section, they didn't mix them up. And so you should keep that in mind. You have to keep in mind that what happens when you mix them up. And in fact, you rarely, with strings, you rarely do this. You rarely do this with strings, because you don't have to, so you don't need to. So you have to remember that, keep in mind the way we did it here. What happens if you think, what's the difference between that and that? Okay, what's the difference between these? Think of these four. What's going on different? S1, S2, S3, and S4. Okay, in the book they do this kind of example, so that gives you two different strings, but they don't point out that, well, if you did it this way, you just get S1, S2 being aliases for the same string. Now, let me do another example here. S6 equal S3. Now that's what, see, now I'm mixing up all the possibilities. S1 cat, S2 cat, S3 new cat, S4 new cat. Then here, S6 is, what does that do?
Would it just assign S3 to S6?
So it's kind of like this. What does it have to do? What's it have in common with this? Line 8 has something in common with line 4. What did line 4 really do?
It'll assign a string
To what?
to S6.
No, what's line 4 do? What's line 4
Oh.
really do?
Line 4 would assign a string to S2.
No.
Or
What did S2 do? Let's visualize it. It assigned a string, but it assigned an alias. See? It assigned an alias. So it created a string object in line 3, and then it just created an alias to the same string it created in line 3. Okay. Now, what's line 8 going to do?
so that would also make an alias.
To what?
It would make S6 the alias to S1.
No.
Oh wait, no, my bad. To S3.
Yeah, so this cat gets an alias now. See, now this cat will get an alias. Okay. See, that cat got an alias. So that created an alias just like that created an alias. Notice now, do you have to know this level of detail? The answer is yes. Okay. Yeah. This kind of thing, when I ask you what does this line do, you really have to start saying, oh, well, it created an alias to that cat object. What did this line do? It created a new cat object, which was separate from the previous cat object, and made S3 a name for it. And this created another cat object and made S4 a name for it. What did this do? Well, this cat is really the same as that one. So that's another alias to that cat. This creates a string variable, doesn't create a string object, so it creates an alias to the same string that this one created. So you've got, notice now I now have I have 6 string variables and only 3 strings. I have 6 string variables and 3 string objects and several aliases. I have 3 aliases. Okay. In the real world of programming, these levels of detail matter. To know whether a program is right or wrong, a lot of times the rightness or wrongness comes from this. Okay. I'm teaching a 400 level a course in programming, and I've got students making mistakes because they still haven't figured out that this and this aren't the same thing. So I've got students sending me emails saying, what's wrong with my code? And they're using this to compare objects. And they're seniors and they're still making that mistake. It's real easy to make that mistake. They've got 2 objects and they want to know if they're equal, and they type this and it doesn't work. But their program compiles, but it doesn't do the right thing. And they're sending me emails saying, what am I doing wrong? And I have to remind them that when you have objects, you don't compare them this way, you compare them this way. It's something you have to start getting used to. You have to remember that because it will make the difference between a program seeming to be okay. The logic looks okay to you, but there's a detail that this equal is not this equal. So even though the program will look like, well, it makes sense to me, it won't make sense to Java because this guy and this guy aren't the same equals. S1 equals S3, S1 equals S3, you read them the same. S1 equals S3, S1 equals S3, but they ask very different questions. So we'll keep going back at this over and over and over again. All right, so we're ready to start loops on Wednesday. So on Wednesday we'll start loops. And like I said, we're going to start solving coding bat problems so that we can see how we think with all this. We've built up a lot of knowledge, but we haven't really made use of that knowledge to solve problems. So we're going to have to start using the knowledge to solve problems. You've been doing it a little bit in your programming assignments, but one programming assignment every 2 weeks isn't enough. So we're going to start doing practice problems where we just keep using this stuff. Okay, so anybody got any last minute question before we're finished? But anybody got a last minute question? I'll put these examples up on the internet, and so please read the section on loops, go over these examples, and then okay, I'll stop. Sorry, we'll meet on Wednesday. And if you have questions, again, always if you have questions about any of this stuff, please send me an email and ask, or come to office hours. Okay, so see you on Wednesday. Goodbye.
Have a nice day. See you then.